Hello everybody, welcome back to a brand new video. Today we are going to react to a Kurzesagt video. I have watched them for a very long time. I do enjoy their videos. They're really good and well produced, obviously. But today we're gonna look at basically what happens if you destroy a black hole. It's like, I'm guessing it's not possible, because how could you destroy a black hole? Like, it's the biggest power mass of the universe. How? I don't know. Let's get straight into this. If you do, however, enjoy these reactions and you want to see more of these reactions, then just go ahead and let me know by commenting it down below or liking the video or even subscribing. But it's up to you. Let's go.
Black holes can destroy everything. But can they be destroyed? What happens if we push physics to the absolute limit, maybe even breaking it and the universe in the process? Let's create a tiny black hole about the mass of our moon in the Kurzesagt labs and try to rip it apart. Experiment 1. Nuke it. Big booms break things, so to set the mood, let's explode the world's entire nuclear arsenal around our black hole.
But that wouldn't work though.
Black holes swallow whatever crosses
their event horizon, would suck it all in.
Matter and energy. And since E equals mc squared, all the energy that enters a black hole increases its mass. The mass of a black hole is proportional to its size, so as we nuke our tiny black hole, it just gets bigger and more massive.
Oh, yeah.
Experiment 2.
That won't work.
Antimatter. Matter and antimatter annihilate each other.
Antimatter, though.
What will happen if we throw a moon's massive antimatter at it? Unfortunately, when an object enters a black hole, the black hole will completely delete its past identity, whether it's made of matter or of antimatter. Black holes only care about gravity, which only depends on the total mass energy of an object. And the mass of a particle is the same as its corresponding antiparticle, so throwing an anti-moon has the same effect as throwing a moon. The black hole
so you can't even throw antimatter into it.
This deleting ability of black holes is pretty interesting. It means that despite their size and power, black holes are, in a way, similar to elementary particles. An elementary particle like an electron is an extremely simple object, fully specified by just 3 numbers: its mass, spin, and charge. And amazingly, the same is true for black holes. They have a mass, they can rotate, and carry an electric charge. Once a black hole forms, it doesn't matter if it comes from a collapsed star.
The thing is, I keep saying okay, like I get it. I don't. I'm trying my best to understand.
An anti-star or a banana, it will always be fully described by those 3 numbers, nothing else. But if a black hole is basically a weird particle, could we destroy it with an anti-black hole?
An anti-black hole?
Anti-black hole. How
what?
Exciting. A particle has the same mass as its corresponding antiparticle, but opposite charge. Since a black hole has mass and electric charge, its corresponding anti-black hole should have the same mass and opposite electric charge. What if we make them collide?
So an anti-black hole would push things out, right? Since it has positive energy, not negative energy. Are there even anti-black holes?
Right.
Huh?
Sadly, the charge will just add up and cancel out. So after the collision, we'll just get a new black hole twice as massive with no charge.
Bruh.
Okay, we need to think bigger and stretch physics harder.
Okay. What could we possibly do else?
Experiment 4. Destroy the event horizon. It's true that a black hole can carry spin and charge, but even for these crazy objects, there are limits. If the spin or the charge of a black hole becomes too large, something really weird will happen. The event horizon will dissolve. In a simplified way, we think of black holes as hiding a singularity inside, an infinitely compressed mass with such strong gravity that absolutely nothing can escape from its surroundings, not even light. This is why a black hole looks like a black sphere of nothingness. The event horizon is the outer edge of this ultimate prison. Cross it, and you'll never be able to come back. But when a black hole rotates, it works a bit like a spinning washing machine. It's as if the rotation wants to repel nearby objects and push them out of the black hole, which doesn't happen because its gravity is so strong. But if the rotation gets too fast, this effect will win and the event horizon will disappear. Nearby objects won't be imprisoned forever anymore. The same thing happens with the electric charge. Make it too large and our ironclad jail will break open. If we manage to destroy the event horizon, the singularity would still be there, and objects would still naturally fall towards it. If you hit it, you would still die horribly and quickly. but the vicinity of the singularity won't be an inescapable prison anymore. You could get as close as you want and come back. This should
that would be really cool, though.
Black hole.
Yeah.
Can we do it? Experiment 5. Overfeeding.
Overfeeding.
All we have to do is to overcharge or overspin the black hole. We could do this by throwing objects with a small mass and a lot of charge or angular momentum so that the charge or spin increases faster than the mass. We have to overfeed the black hole until it reaches the point where it breaks open. However, whether you can actually do this is the subject of passionate argument among physicists.
Yeah.
Think of a charged black hole. Equal charges repel each other, and the more of the same charges you squish together, the more they push back. So let's say that we have a negatively charged black hole, and we want to overfeed it with electrons, for example, whose charge is far larger than its mass. The electrons will feel an electrostatic repulsion, and the more electrons we throw, the larger the negative charge of the black hole will be, and the stronger the repulsion. But once we reach the upper limit, the electrostatic repulsion will be so strong that it won't allow any more electrons to come in. At this point, the black hole will refuse to be overfed. With the spin, it's similar. Once the black hole reaches its upper limit, it won't gobble more spin. But some scientists have discovered what looks like a loophole. If an instant before the black hole reaches the limit, we throw the right amount of matter in just the right way, it looks like we could actually overfeed it. Most scientists are skeptical, but let's give it a try anyway. The end? Breaking physics. There is a catch, though. The event horizon of a black hole hides the singularity. So destroying the horizon would leave us with a naked singularity, one that is not hidden by an event horizon.
I do wonder what the singularity looks like. Because can the singularity have a color? Like, so obviously, like, black holes are black because of it getting sucked into the singularity, but the singularity in itself, because it has to, like, suck in itself, right? So there could be no color. Like, it has to be black, right? Wait, it has to be, yeah, because light can't travel to us. Yeah, I'm stupid. Okay, never mind.
And this poses a problem. It could mean the end of physics as we know it. There's a big dirty secret about black holes. Contrary to widespread belief, the singularity of a black hole is not really at its center. No, it's in the future of whatever crosses the horizon. Black holes warp the universe so drastically that at the event horizon, space and time switch their roles. Once you cross it, falling towards the center means going towards the future. That's why you can't escape. Stopping your fall and turning back would be just as impossible as stopping time and traveling to the past. So the singularity is actually in your future, not in front of you. And just like you can't see your own future, you won't see the singularity until you hit it. But you also can't hit something that's in your future, only sort of experience it, like you'll experience your next birthday when it happens. Singularities that are in the future are not a problem because we can't see them or interact with them. But a naked singularity would be in front of us for all of us to see. What would we see? Well, the point is that it's impossible to know. A singularity is a region of infinite gravity, and gravity is the bending of space-time. At a singularity, the bending is so radical that the fabric of space-time is literally broken. Space and time don't exist anymore. This means that you can't predict anything, since predicting means making a forecast about where and when something will happen. But where and when have lost their meaning. So we have an unpredictable thing with infinite gravity and therefore infinite energy. This means that anything could come out of it for no reason, from a pile of bananas to lost socks or a solar system. Predictability, causality, and physics as we know it would break down.
Well, that's the thing, is like, the way of traveling to the black hole and to the singularity, we know that would kill you. If we then knew a way to actually survive that traveling, because you could technically survive if you are inside of the singularity, or no matter how big it is, I guess, but you could, like, because you don't know what happens. If there's no space and no time, you just float around. Would there be gravity? And, like, anything is possible. But what is in there?
We think that singularities
is it different for each black hole as well?
Because we can prove that under very general conditions, gravitational collapse leads to the formation of singularities. However, scientists think that nature forbids the formation of naked singularities. Something enforces the creation of an event horizon around them to prevent their insanity from infecting the rest of the universe. Without event horizons, physics may not make sense at all. So although black holes have been portrayed as the ultimate monsters of the universe, they may actually be the heroes that keep us safe from the madness of singularities. So if we do destroy the horizon, we might destroy the fundamental rules of the universe. You know what? Let's not do that.
Yeah.
Conclusion.
There's no need.
The safe option. As far as we know, there's just one safe method to destroy a black hole. Wait. All black holes emit tiny particles, a phenomenon called Hawking radiation. This process causes them to slowly lose mass until they eventually evaporate, leaving behind no horizon and no naked singularity. The time it takes for a black hole to completely evaporate depends on its mass. For our mini black hole the size of a speck of dust, it will be about 10 to the power of 44 years. 10 billion trillion times the present age of the universe. So is it possible
that small?
to destroy a black hole? Yes, we just have to wait.
That long?
We don't have to wait that long. There are plenty of fascinating things to explore. Their flow goes on every day.
Well, all right. Right, so we can destroy a black hole. Technically, we can destroy a black hole, but we just don't know what will happen. Like, that could literally break space-time if a singularity, I guess, is unleashed in a way. Well, this is, again, Kurzesagt always makes really great videos. I've watched some of their videos. But yeah, if you have any other videos that you want me to react to, then just go ahead and let me know by commenting down below, or telling me, I don't know, elsewhere. Just meet me in the street, or write me a letter, post it. Anyways, if you enjoyed this reaction and you want to see more of these reactions, then just go ahead and let me know by also commenting it. You can post it if you want, tell me in real life, or just subscribe. Honestly, it's up to you. Anyways, have a wonderful day. I'll see you guys tomorrow, or maybe not. Peace.